All right, so we're going to want to be able to get quick sketches of trig functions that have minor changes to them. So this function here, 2 sine of x, just changes the amplitude. So it's going to go up to 2 and down to negative 2. 2 to negative 2. And you know that that's pi and 2 pi. So just basic facts, they're good to know. This is cosine that's going to be shifted to the right by pi. So here is pi. And it'll end up here at 3 pi because the period of cosine is 2 pi. You know the number here changes the period, so it's going to be 2 pi divided by 4, so pi over 2. So one cosine wave fits between 0 and pi over 2. And I wouldn't scrunch it up, I would just make the x-axis longer. All right, let's look at negative tangent of x. So negative tangent of x is a flipping over the x-axis, so it would look like this. The asymptotes don't change, so there's negative pi over 2, and there's pi over 2. So cosecant is the graph with the cups, so it's going to be here, asymptote here at pi, and down here, asymptote here at 2 pi, where this would be 2 and this would be negative 2. All right, so this is a very important section, knowing how to solve trig functions. So here I have the cosine of theta is negative root 2 over 2. So something like this will come up a lot. So I know that this is where the angles, I'm trying to find the angles, where the x value is negative root 2 over 2. So that's going to be here and here. So the 2 pi over 4 terms. So this is going to be this, which is 3 pi over 4, and this down here, which is 5 pi over 4. So since it says all, you need to write each of them separately and add on a 2k pi. So these are all of the angles that solve this trig equation. All right, so now we're going to deal with the numbers inside the angles. So I want to find the angles, the 2 theta angles that give me the sine of 1/2. So I like to think in terms of pictures. So the sine is a positive sine of the y values, a positive 1/2 here and here. So that's pi over 6, and 2 theta is 5 pi over 6. So for each of these, I need to add on a 2k pi. It's really important you add the 2k pi here now, and then finish solving. To get dividing by 2, you'll get pi over 12 plus k pi, and this one here, you get 5 pi over 12 plus k pi. So these are the answers. So continuing forward, I want to isolate the trig function first. So cosine of theta over 4 is equal to, dividing by 2, I get negative 2. This never happens. We are talking about the unit circle. So there is no solution here. Unit circle meaning of radius 1. Can't get to negative 2. All right, again, let's isolate my trig function, negative root 2 over 2. So again, I'm thinking about the angles where the y values give me negative root 2 over 2. So it's going to be these two pi over 4 terms down here. So my theta over 3 will equal 5 pi over 4 plus 2k pi, and my theta over 3 will equal 7 pi over 4 plus 2k pi. So I'm going to take this and I'm going to multiply by 3. So I get theta is 15 pi over 4 plus 6k pi. And from here, I'll get 21 pi over 4 plus 6k pi. So these two are my answers. All right, so cosecant is not as easily identified as sine and cosine. So I'm going to take the time to rewrite this as 1 over sine 3 theta. So the angle carries along. Now cross multiply, so I have sine of 3 theta is equal to 1. When does that happen? So the sine is equal to 1 up here. So 3 theta is equal to pi over 2 plus 2k pi. So dividing through by 3, this is the answer. All right, so here again, I can isolate the trig function. And so then I'm thinking, what angles are there where the cosine gives me 1/2? So that's going to be here and here. So this is pi over 3, and this is 5 pi over 3. So pi over 3 plus 2k pi. And the angle down here, 5 pi over 3 plus 2k pi. Notice I'm adding the 2k pi on right away, then go solve for the theta. So multiplying by 3, and then multiplying by 3. Okay, so these are my answers. All right, here I have sine squared. And so I'm going to take the square root of both sides, and when I do, I get a plus or a minus 1. So I actually have two solutions. I've got sine of theta is 1, or sine of theta is -1. Let's think about when those happen. Sine of theta is 1 is here. Sine of theta is -1 is here. So I think I can make this short. I could say pi over 2 plus 2k pi. And from this, I could say 3 pi over 2 plus 2k pi, and these would be fine answers. I can join them together and say pi over 2 plus k pi. So start here, add pi, so it doesn't matter which one, it's just nice to know the shorter version. Do one last one for this page. So secant I would rewrite as 1 over cosine of 3 theta, and then I would cross multiply. And cosine of theta is a cosine of an angle is -1 at pi, so 3 theta will equal pi, or any 2k pi multiple. So then dividing through by 3, there are my answers.